Hey everybody, how you doing? Well, welcome to the Epic Flight Academy. I was just out cruising, and we're going to talk about cruising. Actually, we're going to talk about cruise performance and cruise flight. This is the Epic Flight Academy. My name is Mike Thompson, and you're in the Private Pilot Ground School. We are so glad you're here. Now remember, to be successful takes three things. Number one, be studying this course in Epic's online course on Schoology. Number two, watch these videos in parallel to that course. And number three, just as important, be sure to review all of this material with your flight instructor one-on-one. So let's get back to that cruising. What about that? What about that cruising? Well, we're talking about cruise performance. Now, before we can cruise in the airplane, we have to get up to that altitude. That brings us to our first chart that we need to discuss. And that chart is the time, fuel, and distance to climb. And you see that chart here. Let's take a look at this chart. Let's assume in our first example, we're leaving from New Smyrna Beach Airport, which is pretty close to sea level. So when I enter the chart in the left-hand column, I'm going to enter where it says SL, Sierra Lima, and that stands for, of course, sea level. As I move horizontally from sea level, I see my climb speed is going to be 74 knots, and my rate of climb should be approximately 730 feet per minute. But notice it says time 0, gallon 0, distance 0. Those last three columns are giving me my estimated time, fuel, and distance from sea level. So you see this over here on those last three columns to the right near the top, it says from sea level. So I'm starting out at 0. Let's say I'm climbing to 6,000 feet. So I'm going to come down that left-hand column to 6,000 feet, move myself horizontally, and see, oh, hey, look, my best rate of climb speed, or VY, is actually going down. Sure, it's only by 1 knot, but remember, VY goes down as I go up in altitude. So now I'm climbing at 73 knots, and I can expect a climb rate of approximately 505 feet per minute. But notice, it says in the time column, that should take me about 10 minutes. I can expect to use about 2.2 gallons of fuel, and on average, now, not accounting for headwinds or tailwinds, right? These are average figures, probably about 13 nautical miles horizontal distance to get to that altitude. So you see, this chart is actually quite easy to use. This, however, sometimes confuses pilots if the airport they're starting at is not at sea level. Let's say we're flying up in the Midwest somewhere, and maybe I am at an airport, and the airport is 2,000 feet above sea level. So I'm on the ground up in the Midwest somewhere at 2,000 feet above sea level. And I'm going to climb to, let's say 6,000 feet MSL. Now, as you recall, that would only put me about 4,000 feet AGL, but let's use this example. Now, how do I use this chart? Well, I'm going to use it the same way. All I have to do is take a difference. What do we mean by that? All right, let's start at 2,000 feet because that's where my airport is. As I come horizontally, I can see I'm climbing at 73 knots. I can expect a climb rate of about 655 feet per minute. Time to climb about 3 minutes. Fuel used 0.8, and distance 4 nautical miles. See that? Now, hold those numbers in your head for just a moment, and let's go to 4,000 feet, or I'm sorry, we're going to 6,000 feet, right? We're going to climb 4,000 feet. So come into the chart at 6,000. And as I move over to the time, I see it says 10 minutes, 2.2, and 13. The difference that we're talking about is we're going to subtract where we started at 2,000 feet. So let's look at the time column. At 6,000 feet, it's 10 minutes. I'm going to subtract that 3 minutes at 2,000 feet. So how long did it really take me to climb from 2,000 to 6,000? And if you said 7 minutes, you're exactly correct. How much fuel am I going to use? Notice at 6,000 it said 2.2, and at 2,000 it said 0.8. So I need to subtract that 0.8 from the 2.2. That difference is my fuel usage. And the same thing for distance in nautical miles. You see at 6,000 it says 13, and at 2,000 it says 4 nautical miles. 13 minus 4 is, yes, that took me about 9 nautical miles. And that's how you use the time, fuel, and distance to climb chart. Now, once we get up to our altitude, we're going to want to kind of pre-plan what are we expecting in terms of performance. And what we really want from this cruise chart is, what can I expect for a true airspeed and fuel burn? All right, the way that we do that is we go to the pressure altitude that we're climbing to. Now, notice on our cruise performance chart, again, pressure altitudes in the left-hand column. Again, we're climbing to 6,000 feet, so I enter the chart at 6,000. But notice I've got several options here. And those options are my power setting. If you look at 6,000, you see the highest power setting says 2,650 RPM, and then we come down to 2,200 RPM. Well, which one of those RPM power settings should I use? Guess what? That's up to you. You're the pilot in command. You're going to make that decision. Well, based on what? Mostly based on your true airspeed. Do you want to go faster? And your fuel usage. Well, you're going to use more fuel to go faster. If you want to burn less fuel, your true airspeed will be a little bit slower, and it's just a balance between those two. You work with your flight instructor on this, and you just make the decision. You make the call. Do I want more speed and more fuel burn? Do I want more fuel economy and less true airspeed? So let's say, for example, we decided that we want to go at 2,650 RPM. Okay, as I move to the left, notice I'm seeing percent MCP, and you see that right up here, KTAS, and GPH. And that's repeating itself 3 times. It's repeating itself because if you notice up near the top, there is a temperature correction. The first 3 columns are for 20 degrees Celsius below standard temperature. The next 3 are for standard temperature, and the last 3 are 20 degrees Celsius above standard temperature. Now, when we say standard temperature, remember it's got to be the standard temperature for that altitude, not the standard temperature on the surface. That's a critical thing. It's the standard temperature for that altitude. So let's say I'm at 6,000 feet, and in fact, I'm near the standard temperature for 6,000 feet. What would that be? Well, what's the standard at sea level? And if you said 15, you're correct. What's the standard lapse rate? Remember, the atmosphere does not always agree with the standard averages, but just for performance calculations. What's the standard lapse rate? If you said 2 degrees Celsius per 1,000 feet, you're correct. So 15 minus 12, why did I say 12? 6,000 feet, 2 degrees per 1,000 feet, that's 12 degrees. The standard temperature should be 3 degrees Celsius. If it's standard, now it might be warmer or colder, and I would use a different column. So here we are, 6,000 feet, standard temperature, and it says if I select 2,650 RPM, I'm at 77% MCP, 122 KTAS, and 10.4 GPH. Now what are those? Percent MCP is percent maximum continuous power. KTS is knots, true airspeed, and GPH, of course, is gallons per hour. Now, can I run this thing continuously on a cross country at 77% maximum continuous power? I wonder, does it tell me that anywhere in this chart? Of course it does. Don't forget, when we are looking at performance charts, what do we always look at? Notes and conditions. You got it. And up at the top of the chart, you see the conditions, and down at the bottom of the chart, you see the notes. We always look at notes and conditions. Well, our answer is right there in the note. Look at the bottom of the chart. It says, note, maximum cruise power using recommended lean mixture is 75% maximum continuous power. So, at 6,000 feet, at 2,650 RPM, at standard temperature, I'm at 77. That's a little higher percentage than the manufacturer recommends for continuous power. And 10.4, that's a lot of gas. Hey, I'll tell you what if, let's check these calculations. What if we pulled it back to 2,500 RPM? I know we'd save a little bit of gas. Let's take a look. 6,000 feet. Now, let's enter the chart at 2,500 RPM. Let's go over to our standard temperature, and what is our percent maximum continuous power? It says 65. Oh, okay, well that's well below 75, so I'm good there. What true airspeed can I expect? Well, it says to expect about 114. I think I can live with that. I'll make my calculations based on 114. And look at my fuel consumption. It's gone from 10.4 to 9.0. So what I'm going to do is I'm going to make a decision as the pilot in command, and of course I've consulted with my flight instructor, said, hey, I'm going to be the pilot in command, and I'm going to go to 2,500 RPM at 6,000 feet, and the weather tells us we're going to be right near our standard temperature of 3 degrees Celsius, and I'm going to take these numbers, 65%, 114 true, 9.0 GPH, 2,500 RPM, and I'm going to enter those in my navigation log to complete my calculations. Well, folks, I hope that you have enjoyed this short cruise with me through time, speed, distance to climb, and the cruise performance chart. Come and cruise with me again next time. We'll see you later.